Before we understand what exactly is data science, let's start off by answering this question. What is data? What comes to your mind when you hear the word data? So, data is just a collection of facts. When you work with numbers such as 23 or 8000 or 3.14, what you're doing is working with data. When you say statements such as this is Sparta, my name is Jim, or I love pizza, again, you are working with data. So data can be present in the form of numbers, it can be present in the form of text. And it's not necessary that data is only limited to numbers and text. Data can be also present in the form of images. So as you see over here, we've got an image of a car. And data can also be present in the form of videos. Especially right now after the boom of internet and social media, most of the data which we have is actually present in the form of images and videos. So if you look at all of these social media sites such as Facebook, Instagram, YouTube, Pinterest, and so on. So on an everyday basis, you have millions of pictures being uploaded on Instagram. Similarly, on YouTube, you have maybe thousands of videos being uploaded every single day. So what you're doing is generating lots and lots of data every single day. Now, let's actually understand how is the data back then and right now. So when I say data back then, I'd basically mean data around 2 to 3 decades back. So data around 20 to 30 years back was extremely small and it was also structured. So when I say data back then was small, I mean that data back then was present in kilobytes, not even megabytes. So if you'd have grown up in 80s or 90s, you would have known of a storage device called as floppy disk. And there was a time when the maximum storage capacity of a floppy disk was only 512 kilobytes. So you could imagine how scarce data was and also how scarce storage of this data was. So you have a storage device where the maximum storage capacity is only 512 kilobytes. So data back then was extremely small. And data back then was also structured. Since back then you did not have the internet and social media boom, data was mostly present in one single format and it was structured. So when I say data was structured, it was sort of tabular, it was present in rows and columns, and you did not really have any important motive to find out analysis from the data which you had back then. But the data which we have right now, because of this exponential increase, we have terabytes, gigabytes of data being generated every single minute, not even every single day. And all of this data is unstructured. So what is unstructured data? Data which is not present in your typical row and column format. So data which you can't really take and directly fit into a table or into a row and column format is known as unstructured data. So all of your image data, all of your video data can be tagged as unstructured data. And when we are sitting on top of this huge amount of data, it becomes extremely important to leverage this data for our help. So as it is stated over here, when we have all of this data, what are we actually doing with this huge amount of data? So we are supposed to utilize this data to answer business questions. So this is where data science comes in. So with the help of data science, we can actually use all of these insights to increase maybe a company's market revenue, or this can also be used to control the spread of a disease. So right now we have this pandemic called as COVID-19, and along with all of the scientists, you also have the data scientists working on how to control the spread of this pandemic. So data science has its applications across wide number of domains. So now that this is clear, let's actually look at some of the applications of data science. So consider this scenario where you are sitting in your home in India and you suddenly get a call from your bank asking you to verify if you have actually made a transaction of 50,000 rupees in Australia for a diamond necklace. But the problem is, you've never been out of India, you've never been to Australia, and you've never spent more than 20,000 on your credit card. So, why is the bank calling you and asking you if you've actually made this transaction of $50,000 in Australia for a diamond necklace? So this is a fraudulent transaction, and your bank was able to find out that this was a fraudulent transaction, and the bank members or the bank staff immediately called you asking you to verify if this was actually done by you. So how did the bank know that this was a fraudulent transaction? So this is where data science again comes in. So your bank would have been using some back-end data science algorithms and data science techniques where they go through all of your transactions. And by going through all of your transactions, they would know that in general, you do not spend more than $20,000. The maximum you've ever spent is actually 20,000 rupees, and you never spent more than that. And on an average, you normally spend around 5,000 to 6,000 rupees for your credit card transaction. So also you have never used this credit card anywhere outside of India. So suddenly when this data science algorithm sees that there has been a transaction of 50,000 rupees and this transaction has been done in Australia, it immediately tags it as a fraudulent transaction and you get this call to verify if this was actually done by you or not. So this is a very good example of data science application. Then we've got this another data science application. So I believe all of you would have a Gmail account. If not Gmail, then any other email application, you would have at least an email ID. So consider this. If you have looked at the template of Gmail, you would know that there are different sections. You would have your normal general section where you get all of your mails. Then you have your spam section where all of those spam emails go. Then you have promotions, and then you have some other sections. So how does Gmail know whether it's a genuine mail or a spam or a promotion? How does this happen? So again, Gmail is using some data science algorithms and data science techniques at the back end. So what Gmail basically does over here is it does text mining or text analytics. Now, whenever you get a mail, consider these things. So if you look at the subject of the mail, so in most of the spam mails, you would see that the subject will have a lot of exclamation marks, or maybe those entire subject would be in caps lock. Or you could have these terms such as congratulations, you won a jackpot, or emergency, please donate money, or important update, please do this. And also the text of the mail would also contain these sort of terms such as you won a jackpot, you won a reward. So some of the data science techniques have dictionaries, and in these dictionaries you have a positive dictionary and a negative dictionary. So the positive dictionary contains all of the words which are not spam, and the negative dictionary will contain all of the words which might turn out to be spam. So if the count of those spam words is more than the count of genuine words, or if the count of spam words exceeds a threshold, then that mail is tagged as spam. So that is how text mining works. So this again is an interesting application of data science. So now that this is clear, let's actually look at the data science life cycle. So data science life cycle comprises of all of these steps. First, we have data acquisition. Then we have data pre-processing. After that, we will apply machine learning algorithms. Then we will evaluate the patterns which we get after application of these machine learning algorithms. And finally, we would have to represent or show the result. So let's start off with the first step, which is data acquisition. So as I have told you, in this present day and age, data is not structured. Data is unstructured and it is present in multiple formats, and this data comes from multiple sources. So if we would have to solve a problem statement or a business statement, we would have to collect all of this data from different sources. So as you see over here, so this PDF file might be coming from source 1. This Excel file might be coming from source 2. This document might be coming from source 3. So you would have to collect all of these data which are of different types, different formats, and you would collect them and store them at a central storage repository. So you can call this central storage repository as your data warehouse where you're storing all of your acquired data. Now you acquired this data, but the problem is you've got multiple data sets or multiple data points, and all of these data points have different structure. So what you do is you integrate them into a single data structure. So what you do is, since all of these data files have different formats, you will integrate them in such a way that all of them would be of the same format, and that you will store in your data warehouse. So now after you have integrated your data, you can go ahead and find your target data. So whenever you're solving a problem statement or a business statement, you would have to keep in mind that not every data point is essential for you to solve your problem statement. So let's say over here in your data warehouse, you would have 100 files. Now out of these 100 files, only around 30 files would be important for you. Only these 30 files would have the essential information which would help you to solve the problem statement. So you will take only those 30 files, and those 30 files would be your target data. So once you have acquired your target data, you would have to pre-process your data. So this stage is known as exploratory data analysis, and this is the stage in the data science life cycle which takes up most of your time. So normally in the data science life cycle, if let's say if you have a bar from 0 to 100, then 70% or let's say greater than 50% of your time goes over here, which is pre-processing. Because what you've acquired right now is your raw data, and you have to convert your raw data into tidy data on which you can apply your ML algorithms. So under exploratory data analysis or pre-processing, you have two main tasks, which are data manipulation and data visualization. So let's start off by understanding what exactly is data manipulation. So in data manipulation, let me give you an example. So let's say your boss comes up to you and gives you this huge spreadsheet, which let's say comprises of around 10,000 columns and 1 million rows, and asks you to find out all of those employees whose salary is greater than 10 lakh rupees and whose age is greater than 30. So what do? Do you actually manually go through every single record and check the salary and age of the person? Well, that would be extremely time consuming and also stupidity on your part. So you wouldn't do that. So this is where you will use different data manipulation techniques using languages such as Python, R, or SQL. So here, using these languages, all you have to do is just write one line of code, and with the help of this one line of code, you will be able to extract all of the employees whose salary is greater than 10 lakh rupees and whose age is greater than 30. So this is a simple example of data manipulation. Then we have data visualization. Now, again, if we take the same example of this huge Excel sheet, and if you are supposed to find out insights from this Excel sheet, so do you understand anything if you just look at the sheet? Obviously not, right? Because it's just a bunch of numbers or maybe a bunch of text which is present in this tabular data, and this is a huge data set. So what do? Instead of just looking at this table, what if you actually make a plot out of it? What if you make a bar chart or a scatter plot or a histogram or a box plot out of it? So now, if you look at the picture, you will be able to find insights easily when you compare it to just looking at the table. So as they say, a picture speaks 1,000 words, and that is why data visualization is an extremely important part of your data science lifecycle. So this is your data pre-processing stage. So you have got your data, you have acquired your data, and you have pre-processed your data, and you have converted your raw data into a tidy format. Now, after doing that, once you have the tidy data, this is where you will go ahead and build your machine learning algorithms. So we'll understand what exactly is machine learning going ahead. So just for now, as it is stated over here, consider machine learning to be application of intelligent algorithms to find meaningful information from the data. So depending on the problem statement, you will go ahead and apply any of these ML algorithms. So let's say if the problem statement asks you to classify something into different groups, you will go ahead and use a classification machine learning algorithm. Similarly, let's say if your problem statement asks you to predict something on the basis of something, you will use a regression algorithm. Again, let's say if you would have to cluster your data into different groups or cluster your data into different segments, you will use a clustering machine learning algorithm. And now, after you apply these ML algorithms, you will obviously get a result. But you cannot be sure that the result which you get is correct and useful. So this is where you would have to evaluate the result which you get. And this stage is known as pattern evaluation. So whatever result you get, so you have your data, you have your tidy data, you are applying your ML algorithm. After you apply your ML algorithm, you'll get a result. And this result you would have to verify properly. So here what you do is you check for the accuracy of the result, you check for the correctness of the result, and also you check for the usefulness of the result. So let's say you have a result, but the accuracy of the result is only 35%, which is less than 50-50 probability. So you've built the model, you've done all of the hard work, but then again, your ML model gives you only a 35% accuracy. Now, which would mean that the model which you've built is extremely baseline and you would have to tweak it. So also, when I say the model which you've built has to give you useful results. So even though let's say you've built a model, it will give you a result which is accurate. But then again, let's say if the result which you get doesn't really solve your problem statement, then there is no point of using this result. So this is also something which you would have to keep in mind. So you will do pattern evaluation, and after evaluating the result, if you see that the result which you get is correct and useful, that is when you will take that as the final result. And once you get the final result, you can go ahead and show out that result in the form of simple aesthetic graphs to your stakeholders or to your clients. And this stage is known as knowledge representation. So, your stakeholder or your client might not be that technologically savvy. So, if you just give him the technological jargon of what you found out in the result, obviously your stakeholder or your client would not be able to understand much. So, you would have to dumb it down, you would have to simplify it by using aesthetic graphs, and you will add the highlights of what you found out in these graphs, and that is what you will present as your final result. So this is your entire data science life cycle.